Hello, this is Ms. DB, and in this lesson we're going to go over just a couple sample problems from the 10.8 worksheet on finding volume and surface area of spheres. There's an example first for finding volume of sphere. You really just need the formula. You need to make sure that you're working with the radius and not with the diameter. And then you would take the radius cubed, multiply that by 4, divide by 3, and then in terms of pi, you would just do that and then write pi after it. If you wanted the decimal version, then you would multiply by pi on your calculator. So here's an example. They are given the radius of 9, so you would put that in for r, cube it, and then the rest is pretty much a calculator problem. Take 9 cubed times 4 and divide by 3, and you'll get 972, and then don't forget to write the pi after it. Now, sometimes you will be given the volume, and that will go for V in the formula. Here's the formula again. So that's V. And make sure that you see that it's 972 pi, so you don't forget the pi, equals 4/3 pi r cubed. And we're looking for r in this time. Actually, we're looking for a diameter, but we can't find the diameter until we find r. So the first thing you would do is divide both sides by pi. That would cancel that out. Here, let me do that with my pen. Pen tools. Divide the pi from both sides, and then I would multiply both sides by 3/4, which is the same as 0.75 if you want. So if you multiply 972 by 0.75, then you will get 729 equals r cubed. Now the next thing you do, you have to take the cubed root of both sides. The cubed root on your calculator, you may have a cubed root, or you may have something that looks like an nth root, and you have to put in that it's a 3. If you don't have either of those, if you can't find them, you can go to the power of 1/3. That's the same as taking the cubed root. And then you'll get 9 for the radius, and then double that for the diameter. Don't forget that if you have a hemisphere, that's a half of a sphere. So instead of, if you had to find the volume of that, instead of using 4/3 pi r squared, you would use 2/3. That's half of 4/3. Or you can do 4/3, you can find the whole volume, and then just divide that by 2 when you're done. Take the whole thing, divide it by 2, and that will also give you the hemisphere, which is half of a sphere. Surface area is just another formula. Surface area equals 4 times pi times r squared. So if you find the area of a circle, pi r squared, multiply by 4, that's actually the surface area. There is no lateral area in spheres. And then there's some examples. All right, so number 1 is pretty straightforward. Number 2, make sure that you are using the radius, not the diameter. The radius of this would be 8. Number 3 is a hemisphere. That's a half of a sphere. So if you want to use the formula 4/3 pi r cubed, where r is 2 in this case, then you would have to divide that by 2 when you were done. Or you could just start out by doing 2/3 pi, I'll put in the 2, and then go from there. Now number 4 is one that a lot of people had some trouble with because it's asking you to find the radius. So you would put in volume equals, I'm writing down the formula, and this time they're giving me this is the volume. So that will go over here. I don't know r, I'm trying to find r. So just like earlier, I did an example like this. We are going to first divide pi from both sides, which cancels it because there's a pi on both sides. And now I'm going to multiply both sides by 3/4 to get rid of that fraction. Remember, that's the same as multiplying by 0.75 if you prefer decimals. The 3 cancels with the 3, the 4 cancels with the 4, and whatever you get will be equal to r cubed. And then the last step will be to take the cubed root of both sides, which is the same as r, or taking it to the 1/3 power. So whatever you get here, take it to the 1/3 power, and that will be equal to r then. Okay, then we move on to surface area of a sphere, which is equal to 4 pi r squared. R is 7, and you would just finish that up That one's pretty basic. In number 6, the diameter is given as 20, so radius would be 10. Number 7 is a volume question, and it's only a hemisphere. So we can use the formula 4/3 pi r cubed and divide it by 2, or you can just start out taking half of it, which would be 2/3 pi r cubed, and r is 18 in this one. In this one, the volume of the sphere is 4/3 pi r cubed, but we don't know the radius yet. We are given the diameter. So you would divide that by 2 to get the radius. Now, number 9 is one that caused a little bit of trouble. It says the surface area of the closed hemisphere, which is half of a sphere, including the circular base. So we need to take the surface area, but we only need half of it. And then we have to add to that the area of the circle that would be this circular base because they filled that in. So we need that circle as well, which is of course just pi r squared. R here is not given to us. We have to find r because this is the diameter. So you need to find r before you finish this up. All right, and then exploring the effects of changing dimension. Here's an example. The original dimensions, this is the effect on the volume. The original dimensions are when the radius is 3, and they solved this and got 36 pi. Then they tripled the radius, so now the radius would be 9, and they got 972 pi. If we take 972 pi and we divide it by 36 pi, we'll see how much we multiplied this by to get to this. The pi's cancel, and you can use your calculator and divide that, and you'll see it's 27. The original times 27 will equal our new. So if we tripled the radius, we actually have to cube that amount. 3 cubed is equal to 27. So read this. As expected, for volume, if you change a dimension by x, then the volume will increase by x cubed. So for any problem when they're changing the volume by the dimensions of a figure by a certain amount, the volume will change by that amount cubed. And for surface area, here's an example. The original surface area was a radius of 16, and they found this. And then they multiplied all the dimensions by 1/4, and they got this. So to find the change, you take your original surface area divided by your new surface area, and you will see that this is 4 times as big. The old one was 4 times as big. I probably should have done it this way. 64 pi over, so the new one divided by the old one. And then this would be 1/4. So the surface area changes, oh, sorry, not 1/4, 1/16. That's not 4 times as much, it's way bigger. So the surface area, you take how much it changed by, and you square it to find how much the surface area will change. So as expected, for surface area, if you change a dimension by x, the volume will increase by x squared. So you have to square it. So you need to look. This is surface area. So this one you would square it. This one is volume, so you're going to cube how much it changed. Surface area, you square the amount. Volume, you cube the amount. And then finally, we have some examples with a composite figure. You have to find both the surface area and the volume. So for surface area, we don't need to include this. So we're going to need, for the surface area, we're going to need surface area of the hemisphere. So we just need half of, the formula for surface area is 4 pi r squared. So, but we only need half of that. For volume, we're going to need, oh, sorry, that's just the thing, the top part, the curved part, the hemisphere. And then we need, for surface area of the cylinder, we need the lateral, which is 2 pi r, the circumference, times the height. And we also need one base, just this base down here. The other base won't be included, and that would be pi r squared. So if you plug in that r is equal to 9, and for h you would need 12. If you plug that into this formula, you will get the surface area. For volume, you are going to add the volume of the hemisphere, which is 1/2 of 4/3, so that's 2/3 pi r cubed. That's the hemisphere on top. Plus the volume of the cylinder is the area of the base, which is pi r squared times height. And r is 9 and h is 12. So that will give you your volume. For number 15, the surface area is going to be very similar to this one. We have to count, there's the scoop out of it. We have to count that as part of the surface area. So the surface area is going to be that hemisphere, that half of a sphere. And we need half of that. Plus for the cylinder, we need the lateral area, which is 2 pi RH. And we need that one base on the bottom, pi r squared. And let's see, this time r is equal to 3 and h is equal to 7. For the volume, we're going to subtract. We'll take the volume of the cylinder, which is the area of the base times the height, and we're going to subtract the volume of that hemisphere, which is half of it, so that's the 2/3 pi r cubed. So if you correctly can plug in your value for r and h into these formulas, you should get the correct answer for these problems. I hope that helps you as you complete this assignment. Let me know if you have any questions. Thank you.